Okay, let's dive right into this explainer and establish what application security actually means for developers in today's incredibly high-stakes digital landscape. For a really long time, the industry treated security as this highly specialized, almost mysterious discipline. If you go back to the days of waterfall development, security was just another gatekeeper at the very end of a 6-month release cycle. It was usually handled by a totally separate team, the folks locked in a basement office down the hall. But our engineering reality has completely shifted. We live in a world of continuous integration, rapid deployment, and cloud-native architecture. In this environment, security just cannot be bolted on at the last minute. In practice, security is a property that emerges from thousands of small, granular decisions that we make every single day while designing, implementing, and operating software. So today, we're going to unpack the foundational building blocks of modern application security and figure out exactly how to build a robust defense.
Look, we need to start with a bit of a wake-up call here. Almost every single week, we are treated to a brand new headline about a massive data breach at some mega corporation affecting tens of millions of users. We read about the visceral nightmare of a 3 a.m. pager alert, which is then followed by plummeting stock prices, completely shattered user trust, and sometimes even congressional hearings. These relentless incidents absolutely prove that a serious security flaw can literally end a company. And what's more, the actual nature of the threat landscape has fundamentally changed. We used to think we could rely on the underlying hardware to magically isolate our workloads and protect our applications. But recent years have definitively shown us that, no, we are dealing with stack-wide vulnerabilities. The perimeter as we knew it has completely dissolved.
Which brings us to the big question I want you to keep in the back of your mind throughout this entire explainer. With both hardware and software vulnerabilities routinely affecting millions, how can developers stop being the weakest link? Seriously, how do we take intentional control of our code and ensure we aren't the ones leaving a catastrophic window wide open for an attacker? Well, we have to completely stop treating security as a post-development afterthought. We have to start engineering it from line one. Here is our roadmap for this explainer. We'll be looking at 1, the cost of insecurity. 2, security in daily development. 3, the security skills pyramid. 4, software supply chain risks. And finally, number 5, the information security village. Okay, section 1, the cost of insecurity, hardware to software. So, in the past, we depended heavily on hardware walls. The general assumption was that the operating system and the CPU would neatly isolate your application's memory from everything else running on that physical machine. But then, in 2018, the Meltdown and Spectre vulnerabilities were disclosed, and they completely shattered that assumption overnight. These flaws exploited a feature in modern processors called speculative execution. Basically, the CPU guesses the next instructions to save time, leaving these tiny little traces in the cache memory. Well, attackers figured out how to read that cache, literally bypassing CPU hardware protections to access unauthorized memory. Imagine you're operating in a multi-tenant cloud environment like AWS or Azure. One tenant could potentially see the raw memory of another completely unrelated tenant on the same physical server. Those hardware walls we blindly depended on were suddenly full of holes. And because we can no longer rely purely on the underlying infrastructure to save us, application-level security has become a collective, absolutely non-negotiable responsibility for every single software engineer. Your application simply has to be resilient enough to defend itself. Moving right along to section 2, security in daily development, the developer's reality. Imagine a really naive implementation of a database query. A developer builds a simple search bar on a website, takes the user's input, and just concatenates it directly into a SQL statement. The resulting code is a basic instruction: select all columns from the products table where the name equals whatever the user just typed in. Now, at first glance, this looks completely harmless, right? It's a classic, deeply ingrained daily coding habit that a lot of us learned way back in Computer Science 101. But this exact pattern opens the door to one of the oldest, yet most devastating classes of attacks on the web: SQL injection. We are grounding the theoretical concept of security right here in the basic logic you write every single day. So let's play this out. What happens when an attacker decides to get a little creative? Instead of typing a standard product name, the user inputs this exact string: a quote, a semicolon, drop table products, another semicolon, and a double dash. The initial quote elegantly closes the developer's original string, but then comes that semicolon, which acts as a statement terminator in SQL. It's essentially telling the database engine, okay, the first command is done, now execute the next one. And the database obediently executes the drop table products command, completely wiping out your inventory data. Finally, the double dash comments out the rest of the original query so it doesn't throw a syntax error. Boom, data's gone, and you are left with a very, very uncomfortable, totally unplanned meeting with your database administrator in HR. This is exactly why a security-first mindset is required at the keystroke level. To prevent disastrous things like SQL injection, we really need to realize that security isn't just a single checkbox at the end of a project. It's a continuous, integrated cycle. Let's break down the software development lifecycle. It starts right in the design phase, where you must proactively define your trust boundaries. Mapping out exactly where data crosses from the untrusted public internet into your trusted backend systems. Then comes implementation, where you have to rigorously validate and sanitize inputs to avoid what we literally just saw with our database example. Next is dependency management, which is all about carefully selecting and vetting third-party libraries so you don't accidentally import malware. Then configuration, which means setting secure defaults, like ensuring your servers only accept modern TLS encryption protocols, and explicitly disabling the older, vulnerable ciphers. And finally, deployment and maintenance, where you rapidly patch vulnerabilities and automatically rotate your cryptographic secrets. Security weaves through every single one of these stages. It's the whole shebang.
Now, because the business impact of a breach is so uniquely catastrophic, executives now place some pretty major expectations squarely on the shoulders of developers. You are expected to correctly utilize all available product security features. You must meticulously follow corporate security standards. You need to proactively design secure applications right from the ground up. And critically, you must enable DevSecOps transformation. And listen, this isn't just a management buzzword. True DevSecOps means breaking down organizational silos so that security is actively discussed in your morning stand-ups and your sprint planning meetings, not just 5 minutes before a production deployment. Security has officially shifted from a post-development afterthought to an intrinsic, everyday engineering requirement. Section 3. The Security Skills Pyramid, a paradigm shift. Let's deconstruct how we actually build secure systems. At the very peak of this pyramid, we have our ultimate goal, secure applications. To achieve that, those applications rely really heavily on a middle layer made up of complex libraries, frameworks, and corporate security practices. But all of that is supported by a foundational bottom layer, standards, protocols, and patterns. This foundation is made up of language-agnostic mathematical truths, things like OAuth 2.0, OpenID Connect, and TLS. These foundational protocols do not magically change or deprecate every single time a new JavaScript framework is released. They are literally the bedrock of the entire internet. But here's where we hit a massive disconnect in how the industry currently learns and operates. The vast majority of developers spend all of their time wrestling with the middle layer, the specific libraries and frameworks. You might easily spend weeks pulling your hair out trying to master the configuration nuances of something like Spring Security. It feels incredibly frustrating and cumbersome, acting like a complete black box, right? Well, why is that? It's because developers often skip learning the foundational layer. If you invest the time upfront to deeply understand the underlying protocols, if you know exactly how an OpenID Connect authorization code flow works over the wire, then using those complex frameworks suddenly becomes trivial. You are no longer blindly copying and pasting code from a forum. You are simply mapping standardized concepts you already understand into YAML files. You absolutely have to build that foundational knowledge first. It's a real game changer. Section 4. Software Supply Chain Risks, the Invisible Threat. 106. That is the average number of open-source third-party libraries sitting inside a standard baseline Spring Boot application today. And frankly, if you're working on a mature enterprise application, that number easily balloons to over 250 dependencies. This happens because of transitive dependencies. You might import one handy little logging library, but that library imports 5 others, which in turn import 10 more. Suddenly, you have hundreds of completely invisible packages running in your production environment. Now, reusing software components obviously saves a huge amount of engineering time, but it introduces a massive, often unmonitored attack surface. If just one of those 106 libraries has a critical flaw, your entire application and your company's data is fully exposed. If you want to understand the true gravity of ignoring that supply chain attack surface, we just have to look at the 2017 Equifax breach. A severe vulnerability, CVE 2017-5638, was discovered in the wildly popular Apache Struts framework. A patch was made available in early March. However, Equifax failed to apply it. By mid-May, attackers discovered the unpatched system. Because the vulnerability was ignored for months, the attackers were able to just sit inside the corporate network, slowly traversing systems and exfiltrating data bit by bit to avoid triggering any alarms. The end result? a catastrophic data breach exposing the highly sensitive personal information of 150 million citizens. The fallout included congressional investigations, ruined reputations, and over $1.4 billion, with a B, in cleanup costs. This is a terrifying reality check of what happens when a single unpatched dependency in your supply chain is forgotten. So, how do we fight back and actually secure our supply chains? First, strictly utilize publicly documented APIs in your code. Using internal or undocumented methods means your code will inevitably break during an upgrade, which makes developers terrified to apply security patches in the first place. Second, utilize automated vulnerability scanning in your CI/CD pipelines. Tools like GitHub's Dependabot operate in the background, parsing your manifest files and automatically generating pull requests the moment a vulnerable library needs an update. Third, embrace modern AI-assisted code review tools like CodeRabbit. These tools analyze your pull requests to flag insecure patterns natively in your workflow before a human reviewer even needs to look at it. And finally, the golden rule: rigorously keep all of your components updated.
Section 5, the Information Security Village. You are not alone. I absolutely love this concept. The Information Security Village represents the vast, incredibly diverse ecosystem of specialized roles required to secure modern systems. Why a village? Well, because modern distributed software architectures are simply too vast and complex for one single brain to fully secure in a silo. What this metaphor tells us is that effective application security requires collaboration over isolation. You don't have to carry the entire burden of defense all by yourself. You have a highly specialized community around you. Think about it. We have mathematicians theorizing algorithms and cryptographers building robust ciphers. We have standards engineers codifying those exact concepts, and framework engineers packaging them into the libraries you import. We have corporate InfoSec defining identity boundaries, auditors verifying compliance, and yes, even ethical hackers aggressively pushing the boundaries to find weaknesses before the bad guys do. As a developer, you don't need to be a brilliant cryptographer. But if a compliance auditor asks for your system logs, or a corporate InfoSec engineer needs to review your identity access management boundaries, you must be able to speak their language. Knowing those foundational standards we discussed earlier allows you to be a highly effective collaborative partner in this village. I really want to reinforce the core message of this explainer by slowing down for a second and focusing on this exact quote from the source material. Security is everyone's collective responsibility to build and run IT systems. Regardless of your role in the IT world, security is your responsibility. This completely shatters that legacy misconception that security is strictly an InfoSec team's problem. From the hardware engineers designing silicon processors all the way up to you, the application developer writing a simple database query, we are all part of this continuous chain of defense. So I want to leave you with this final provocative thought to carry into your next sprint planning session. Are you building software that is secure by design or secure by accident? If you are blindly relying on heavy frameworks without understanding the protocols beneath them, or if you're ignoring your transitive dependencies, you might just be getting lucky. It's time to master those foundational security standards, fiercely protect your software supply chain, and embrace the collective responsibility of the InfoSec village. Thank you so much for joining me on this explainer. I really hope this deep dive sparks a new level of intentionality and curiosity for your daily development workflow.